Hello there, function folks. We've got a strange day ahead of us. Strange lessons, 3.5 trig graphs. A lot of this is review, and except for we're not talking about degrees anymore, we're talking about radians, and so that's what's new. First of all, I want to explain how this is going to go, because it's going to be another one of these little back and forth business. In this video, I'm going to take up the 3-minute review, which is up there, and you've tried it, of course. And then I'm going to talk about two activities that you're either going to do as soon as you're done the 3-minute review and try it yourself, and I'm going to take these two things up in this video, or you're going to save these for class, and that'll be up to you. Then later on, I'm going to do, you're going to do another activity in class. This is just a handout to fill out, and I'll take it up and talk a little bit more about the graph of y equals tan theta. And then the third part is a short lesson on graphing reciprocal graphs of trig graphs, because we've done reciprocal graphs before, of course, when we did rational functions. This is reciprocal trig graphs. So let's get into it. The 3-minute review is hopefully less than 3-minute review, especially when it's set up like this. When the grid's already set up, sine starts at the origin and important points every 3 ticks. We used to last year say every 90 degrees, but it's every pi over 2 or every 3 ticks. And yeah, there were other points that we did on that table last class, but these are what I call the important points. Important points every 3 ticks, every pi over 2, and it repeats the pattern, periodic. Middle, high, middle, low, middle, high, middle, low, and I could keep going forever if I wanted to. Okay, and we try and make this nice, smooth curves, no teeth, shouldn't look like teeth, nice, smooth curves, and this is y equals sine x. Maybe more challenging is to remember the scale if it's not there in front of you, and again, you should be doing this or did this on your own. If you did them on the same grid, well, that's okay, except for you still have to remember the scale yourself. Every 3 ticks, important point. Every 3 ticks, 2 pi over 2, important point, pi. 2 pi over 2 is pi. Every 3 ticks, important point. And I'm just ticking off the important points. And of course, with this scale, each normal tick is pi over 6, right? And we've had some practice doing that. I forgot to put my y scale, and it doesn't matter how far up I go. I could make that one. One of the things we're going to worry about soon enough is transformations on these. Yep, we are doing transformations again. Of course we are. And the difference between cos, and that's how we're getting started today, is the difference in similarities between these two graphs. Cos starts at its maximum. It starts at 1, goes high, middle, low, middle, high, and the pattern repeats, okay? And so, that's cos x, y equals cos x. And I don't need to remember any other points. Maybe your grade 11 teacher asked you to do more points than that. This is what I call the 5-point method. And important points, those are these ones, occur every pi over 2. Right? Important points every pi over 2. Okay, and that's cos x. And you should be able to do this without even thinking. Just, bam, it's done. Because we're going to be doing lots of neat stuff with them soon. So the next 2 exercises, and you shouldn't sneak a peek here, but I will explain it. In this video, I'm going to take these 2 things up. There's a sheet that's called Venn diagram exercise, and the idea is you're going to get this piece of paper and you're going to chop it into a bunch of bits. And then you're going to follow the instruction, and it's the idea of how are these 2 graphs the same and how are they different. And when you get through that exercise, you should have a Venn diagram. The Venn diagram, don't spoil it for yourself now. Do not look at the next few seconds unless you've tried this exercise. There it is right there. There's my version. Okay. And these are the things that are not they're not properties of either graph. Notice all of our stuff is in radians. Okay? And so hopefully that was sitting on your desk or you're looking at this on your phone. And then what the idea is you use this information, and maybe you didn't need this information, but that this is a good exercise, is to fill out what are called the Fraser sheets. The Fraser sheets, and there's going to be a pile of them in your package, look like this. Now, I've got my answers in already. You shouldn't be copying. You should be trying these on your own, and then trying them on your own, and then checking them later. Okay, so this is the Fraser sheet for y equals sine x, and you'll fill in the blanks. And the idea is then you can write in anything that you want to about sine x. Maybe you do a little sketch so you remember that it starts at 0. The y-intercept is 0, the starting spot. All right, so don't spoil it. Try it yourself. And here's cos x. There's the cos x one. Okay, you can pause the video. That's it for this first video. The next part is me talking about the graph of y equals tan x, which is brand new stuff. You haven't seen y equals tan x, but you will be filling out a sheet first before you watch the video that looks something like this. Maybe there's a hole there. I don't know. So this is the next sheet to do, and you're going to be doing that in class. Part 2 is me taking this page up.